So this talk is called Boscovich forces. There are symposiums on Boscovich, and I'll be dealing with one of them, or more specifically a paper presented at one of the symposiums. This is where it got published. It's called The Philosophy of Science of Roger Boscovich, and you note it's not a physics institute that this is from, but it's still dealing with physics. So this is a picture of the person Boscovich. He was a priest, but he was also deemed a scientist and philosopher, and he dealt with what we now call physics. So this is the article I will be dealing with, but from Ivo Slaus, and Boscovich is sometimes spelt Boskovic. As per Wikipedia, Ivo Slaus is a nuclear and particle physicist. And this is Ivo Slaus getting presented with an award. Ivo Slaus is from the Roger Boscovich Institute, and has been in various other places. So Ivo Slaus' article starts: Roger Boscovich, and Roger, R-U-D-E-R, normally gets translated into English as Roger, was one of the founders of modern science, and it is thus natural that we encounter his ideas and his theories in contemporary science, meaning physics. His studies continue and extend the work of Leibniz and Newton. In his theory, that's his book, Boscovich's book, first published in Vienna in 1758, he writes, and I was quoting Boscovich, "The following theory of mutual forces, which I lit upon as far back as the year 1745, and from which I have derived the very constitution of the simple elements of matter, presents a system that is midway between those of Leibniz and Newton. It has very much in common with both and differs very, very much from either. I take from Leibniz simple point particles, and from Newton I take mutual forces, attractive and also repulsive, which Newton treated in his Optics book. My theory differs from Leibniz in not allowing continuous extended primary particles, and he differs from Newton in reducing all forces to one force instead of three Newtonian principles: gravitation, cohesion and fermentation. Also, at small distances I introduce a repulsive force which becomes infinitely repulsive as distance tends to zero. Thus it follows that the cohesion does not stem from contact, and indeed immediate contact is not possible." So what he's talking about is point particles which never come into contact. And it quotes Boscovich further: "The primary elements of matter are, in my opinion, perfectly indivisible and non-extended points. They are so scattered in an immense vacuum that every two of them are separated from one another by a definite interval. Now, the law of force is of this kind. The forces are repulsive at very small distances and become indefinitely greater and greater as the distances are diminished indefinitely in such a manner that they are capable of destroying any velocity, no matter how great it may be, with which one point may approach another before the distance between them vanishes. When the distance between them is increased, they are diminished in such a way that at a certain distance, which is extremely small, the force becomes nothing. Then, as the distance is still further increased, the forces are changed to attractive forces. These at first increase, then diminish, vanish, and become repulsive forces, which in the same way first increase, then diminish, vanish, and become once more attractive, and so on in turn for a great number of distances, which are all still very minute, until finally, when we get to comparatively great distances, they begin to be continually attractive and approximately inversely proportional to the square of the distances. And he refers to figure 1. And this is the figure 1, where it's showing that the force keeps changing from attractive to repulsive with distance. So modern physics is built on the idea of point particles, as Wikipedia explains. A point particle, ideal point or point-like particle, often spelled a point-like particle, is an idealization of particles heavily used in physics. And you can read the rest of that. And basically this is the idea upon which modern physics is built, the idea of point particles. Unfortunately, there's often a great deal of resistance by some people towards the idea that physical reality is built from point particles, because it goes against their intuition of solidity. You sort of like, I'm sitting here and I've got a table in front of me. Most people think that table is solid, but in Boscovich's theory, it's made up of point particles in what is empty space. So it's not really solid. It's just to our senses that it looks solid. And so if you touch it, you're really interacting with force fields. It's not really solid, contrary to what our senses are telling us. Evo points out the similarities of particles obeying curves similar to Boscovich's curve at subatomic and other levels of matter. And I'm going to refer now to some of the more interesting things said in the article. This is the article again. Boscovich considers that his law of force is valid not only for elementary particles but also for composite particles, and he follows Newton's reasoning that the force between elementary particles is stronger than the force between composite particles. So if a particle is at point E, which is shown in his diagram, and it is being moved towards point F, then under the influence of the attractive force it will return towards point E. If it's moved toward A, the influence of the repulsive force will return it to the point E, and so on. So I'll remind you the diagram, and in the diagram you can see a point E and so forth. Boscovich's theory of forces and point atoms was immediately accepted by his contemporaries and profoundly influenced the development of science. So I don't really like the term point atoms because you can get it confused with the chemical atoms of Dalton, I feel. So I prefer to call it point particles. But that's what it is, sometimes referred to as point atoms. And when he talks about acceptance, I think there is probably a lot of arguing. It was acceptance by some. Anyway, it carries on. The wide acceptance of Boscovich's ideas was due to the high esteem that he enjoyed, as well as to the fact that similar ideas were developed by other scientists and philosophers, e.g. Kant and Mitchell. The most important reason is certainly the simplicity and the beauty of his theory, which attempted to explain a variety of physical phenomena using a single force, which formulated a strategy for the investigation of the structure of matter. Now, Boscovich's force switches between attractive and repulsive according to that figure 1 diagram. And Ivo carries on. Boscovich's influence is evident in the work of his contemporary Priestley, who calls Boscovich one of the greatest mathematicians and philosophers of our time. Starting from Boscovich's theory, Priestley argues that differences among chemical elements are due to different structural patterns. Priestley also used Boscovich's theory in his theological treatise and attempted to reduce the soul to point atoms. In 1778, this caused bitter arguments between Boscovich and Priestley, which ended their friendship. So you've got this theory of physics, and unfortunately people will try to extend it to other things, such as religious beliefs. Ivo carries on. In 1785, Robinson taught Boscovich's theory in Edinburgh, calling it the most ingenious theory, and I venture to say that if we ever will have a true theory, it will resemble the theory of Boscovich. Thomson, in his System of Chemistry, said that Boscovich provided the most complete explanation of cohesion. So what I know is part of the physics system at one time until it was I know it was part of the physics education system at one time until it was dropped. I think at the time in question professors might have had a bit more freedom in what they chose to teach, but there is standardization across education system now, when the tendency is to want to teach every student, no matter where they are, the same basics. Thus things like Boscovich get dropped from the education system. Ivo continues, particularly important is Boscovich's influence on four great men of science, Davy, Faraday, Kelvin and Thomson. Though by discovering chlorine in iodine, Davy even increased the number of chemical elements, he believed that matter is composed of fundamental particles and that phenomenological differences are due to structural differences. He found confirmation of his ideas from the fact that graphite and diamond, though very different, are only different structures of the same chemical element, carbon. Boscovich's theory, as distinguished from Dalton's atomism, explains, according to Davy, all chemical phenomena. In his Elements of Chemical Philosophy, Davy wrote, assuming that the forces between molecules are attractive and repulsive, as Boscovich does, it is possible to explain all phenomena in chemistry. Evo continues, Faraday, after conducting ingenious experiments, finally accepts the idea of repulsive forces and of point atoms. Thus, in 1889, Kelvin considered that Boscovich's ideas are obsolete and that his theory is infinitely improbable. However, later in 1900, he modified his view, stating, my present assumptions are Boscovichian, pure and simple. J.J. Thomson was aware that the accelerated charged particle radiates energy, and therefore the model of an atom with its nucleus in the focus and the electron moving along the ellipse cannot be correct, since an atom is unstable. Using Boscovich's concepts of allowed and forbidden orbits, Thomson formulated a model of an atom in 1906, which was a few years later elaborated by Niels Bohr to include the mechanism of absorption and emission of radiation through the transitions of electrons from one orbit to another. And I note Bohr's model of the atom was the early stages of quantum mechanics. And so you've got Boscovich's theory, which is being used to create this model of the atom, which Niels Bohr had. Evo continues, Prout's hypothesis that all atoms are composed of hydrogen atoms also reflects Boscovich's ideas. Anticipating modern quantum theory, Boscovich explained the finite size of solids. Though he starts with point per atoms, the distance where the force changes from the repulsive to the attractive is responsible for the basic properties, and it can be compared to Heisenberg's universal length in his grand unified theory. Now, Heisenberg's unified theory is usually ignored as well, and when it says about anticipated modern quantum theory, that's really what it means is quantum theory was the development from Boscovich's theory. As I carry on reading what Ivo says, according to the modern superstring theory, elementary particles are oscillations of a one-dimensional object string in a 10-dimensional space, 9 space and 1 time dimension. I also note that Bohr was aware of Boscovich's theory and quantum mechanics was the development based on Boscovich's theory. Carrying on what Evo says, Boscovich does not consider mass to be a fundamental property. An aim of modern science is to derive the masses of particles, electron, muon, proton, etc., from a general theory. Boscovich critically evaluated Newtonian concepts of absolute space and absolute time, and thus can be considered a forerunner of Einstein's theory of relativity. And as I pointed out in several of my videos, Einstein was working for Boscovich, so that's what the sense of forerunner of Einstein's theory of relativity is about. Modern physics education unfortunately takes Einstein as the starting point from which to start teaching about such things as relativity and quantum mechanics, and ignores the influences that Einstein was working from. Carrying on what Evo says, here Boscovich discusses the basic methodology of science and points out the limits of science. Though the limits of science constantly expand, science does not and cannot provide answers to all questions. Science is a part of culture, and Boscovich, who had contributed so much to science, is fully aware of the limits of science and argues the domain of science should be extended without using technological arguments. Boscovich returns to the question of final causes again in the appendix of his book on this theory, and in this way illustrates the complementarity but also the interconnection and overlap of these approaches in our search for truth. Evoking carries on and he says, there are several rather amusing relationships between the values of various natural constants, e.g. the radius of our Earth is the geometrical mean of the radius of the universe and the radius of an atom. The mass of man is the geometrical mean of the mass of a planet and the mass of a proton. The ratio of the electric and gravitational forces is also equal to the age of the universe expressed in timescale characteristic for elementary particles. Life depends very critically on the values of various physical constants. For example, if the ratio of the strength of the nuclear and electric forces would be only slightly changed, processes which lead to the production of carbon and hydrogen from helium would not yield abundances of the elements which are necessary for the existence of life. Similarly, the supernova explosion depends on the ratio of the weak and the nuclear forces. Supernova explosions are necessary if the heavy elements which are essential for life are to be spread from their production site throughout space. Therefore, it seems that the structure of the physical universe is such that the conditions for the existence of observers are fulfilled. This is the so-called anthropic cosmological principle. So from Boscovich's theory, you are ending up noticing all these similarities in the mathematics, and there are some that would argue that is not science stroke physics, but that isn't all on the basis of what physics was built upon. It was built upon the consequences of a point particle theory, and to know some of those consequences is just a person wanting to be awkward. Same it is a person being awkward who does not want to consider physical reality as being made from point particles, since it conflicts with what they want to believe. So we see the conflict here between what is the unified theory of Boscovich with people's prejudices. So I'd like to now point out the demarcation between physics and metaphysics. Physics tests ideas with experiments. Metaphysics is beyond physics, and it deals with ideas that can't be tested. The idea that the physical universe is made from point particles is not really an idea that can be tested, so it's a metaphysical idea. It is, however, the metaphysical idea upon which modern physics is based. And if you wanted to go on to something else, like thinking physics is based upon superstring theory, well, superstring, well, that's a metaphysical idea as well. So I suspect in the physics education system that wants to stick only to physics and avoid metaphysics as much as possible, quickly glosses over the metaphysical foundation of physics being point particles, because if it didn't do that, then it would be diverted too much onto other metaphysical issues. So we've set up a physics system that wants only to deal with physics, and it then wants to avoid the metaphysics that has led to that physics. And that is where we are at with Boscovich's theory. Boscovich's theory is the foundation for modern physics, but the metaphysical parts of it are what the existing physics establishment wants to leave out of the physics education. And that's the end. Thank you. Cheers.